bits. So let's check which one is for what. So the first one is for woodwork, so which is having a very sharp tip on the edge. The second one is for brickwork, concrete work, or the combination of both is called masonry work. So the design will look like this. The last one is for metals, so the design looks like this.
Twist drill is the most common type of drill used for drilling. In any drilling operation, twist drill is fixed by a drill chuck, which is attached to the drill press. Twist drill has a cylindrical structure with deep helical grooves cut on it running lengthwise throughout its body. Now let's study the geometry of the twist drill in schematic view. Twist drill consists of two main parts, shank and body. Let's first study about shank. It is the upper cylindrical smooth portion of the drill which is used for gripping and driving the drill. It is tapered so that it can be easily inserted in the drill chuck. The upper end of the shank is flattened and is called as tang. It receives and transmits the drive feed. Now let's study about the body of the drill. It is the lower part of drill which runs from below the shank to the cutting point. First, let us see the front view of the drill body and its parts. It consists of a neck at its upper end, whose diameter is smaller than the part of shank present above neck, and the rest of the body. The neck separates the main body from the shank. As we move below the neck, we see that two helical grooves present on the surface of the main body throughout its length. These helical grooves are known as flutes. The main functions are to provide clearance to the chips produced at their cutting edges, and to allow an easy passage to the cutting fluid to reach cutting edges. Now let us focus on the leading edge of the flute. We see that there exists a cylindrically ground narrow strip. This is called land or margin. The function of it is to keep drill aligned during drilling operation. Now let us consider any point on the leading edge of lead. Now we see that on the same leading edge point appears in the same position after one complete revolution. The distance measured parallel to the drill axis between these two points is called lead. Now let us take a closer look at the tip of the body. We see that at the bottom end there are two conical parts known as cutting lips. The surface of the drill which extends from the cutting lips to the respective flute is called the flank. The portion of the flute surface adjacent to cutting lip is called the face. It facilitates the removal of chips from the workpiece. The length of the edge formed by the intersection of face and flank is called the lip length. Note that the lengths of both the cutting lips are kept equal to produce a uniform whole. The cone-shaped sharpened edge of the drill that consists of flank, face and cutting lips is known as point. Now let us see the bottom view of the body of the drill. We see that both the flanks intersect each other at this line. This line of intersection is known as the chisel edge. The thickness of the drill between the flutes is called the web. Note that the size of web increases along the length of the drill. This is done to provide strength and rigidity to the drill.